Now let's move on to one last option to show you what we're doing. Let's test the servos. So we have a fresh new syntax document. Lost my train of thought there. Talent servo test. Going to give it a counter. This time will be a word, so we're going to use a pretty hefty size option with our loops. We're going to avoid doing any sort of frequency tests. Not a big fan of them right now. They are kind of annoying. And check out how we do a for loop. Counter 1 to 24. This will give us, this will automatically increment, so you don't need to do this, counter plus plus, something like that you would see in C++. This is going to be a pretty straightforward for loop between 1 and 4, or 24. Now, this is a trick where we were having this, previous options were set at the 3-part switch that's set at 1, which disconnects the servos. We'll have that switched to now option 2 and have it power the servos. Now, the problem I do see here is that my servos on the board are on output 13. I also have my LEDs are 13 and 12. My LEDs I have plugged in are in 13 and 12 as well. This means when I power or pulse the servos, they will also light up my LEDs. I think this is something that it took me a few minutes to make this correlation that the breadboard and also servos at the top are on the same rail. This is not a bad idea to make sure that if I am powering 1, I should be able to see visually what's happening. So let's check out what we have. Pulse out. That means it's going to the servo. Pin 13 for, I believe that's duration is 850 milliseconds. Pulse out 12 for 650 milliseconds. You're going to kind of wonder, why are we doing this? In the book, they have you balance your servo motors at 750 milliseconds. So this means that at that point is dead stop, no movement either direction. Anything more than that will give you positive forward rotation. Anything less will give you back rotation. Now, also you have to think about this. To get both wheels spinning the same direction, you need to have one going forward and one going backwards. Remember, their axles are pointed, out like you normally would with a car. So you would have, so one basically would be forward and one back. What we're going to do is we're going to send this thing, we're going to send it forward for a count of 24. Save that. We're going to call it servo test. Plug everything in. Powered on. And there you go. It's a pretty quick, short hop forward. Now, let's try adding something else in there. Try to throw a pause command, 200 milliseconds. And we're going to get another for loop and send both of them to one direction. This should effectively turn our Bobot one way. Cool. Pause this again. Turn it the other way. Pause it again and send it backwards. Notice how the pulse out on these two are different. One's going forward, one's going backwards. You might remember this. This would be the part of the small code I had for my first video. See what happens when we do this. Cool. So that should finish up, give you a pretty good idea of what you're looking forward to when you write code for this. If you're looking for something complex, some sort of threading, this is not going to be the option with the Bobot. Now with the FAS2 Panda boards with a better processor, more space on it, optional space, you can write some pretty complex, heavy applications with the .NET Macro framework. But in the stamp editor, not so much. But even with this much, you can look into things with servers, sensor responses. So if it bumps into a wall or if it follows a particular line, we can get feedback from those sensors back into the board, and it records that, and we can act accordingly. Now that's going to be for a different day, a different project, but right now I just kind of wanted to get your feet wet with what to expect for this. Until next time, bye-bye.